And welcome to Child's Academy. Our today's lesson is about graphing a quadratic relation using the 5 steps from factored form. Now, to find the direction of opening, the very first step, you look at the leading coefficient of degree 2, this factoring polynomials, which is negative. So even if you were to expand, you still should be able to look at the coefficient of x squared, see if it's positive or negative, and I'm sure in this case will be negative because negative 2 times 1 is negative 2. Negative 2 times 1 here also would be negative 2, which is negative. So since the coefficient of x squared is negative, parabola or the direction of opening will be downwards. So down. To find y-intercept, which is the second step we mentioned in previous video, to find y-intercept of any relation, we substitute for x 0. So in order to find y-intercept, I'm going to show it right here, the steps y equals negative 2. We substitute for x 0, so 0 plus 2, and 0 minus 4, and this would equal to 0 plus 2 is 2, 0 minus 4 is negative 4. This is going to be negative 2 times positive 2 is negative 4. Negative 4 times negative 4 is positive 16. So our y-intercept would be positive 16. And it's a point on the graph. When x is 0, y is 16. How do we determine the x-intercepts or zeros? Since it's factor form, it's a lot easier to find our zeros and x-intercepts. We substitute for y 0 and we solve for x. So let's do that. Substituting for y 0 and solve for x and the given relation. Negative 2, 0 equals negative 2, bracket open, x plus 2 and x minus 4. Now, to get rid of the coefficient, you can divide both sides by negative 2. So when she did that, to get rid of it, which will not affect finding your zeros or x-intercept, so 0 equals x plus 2 and x minus 4. Now we set both of these pair of brackets equal to 0 in order to isolate for x to find the zeros. So x plus 2 equals to 0 and x minus 4 equal to 0. And we isolate for x, bringing the positive to the other side would be negative 2. And here would be positive 4. So the x-intercepts are, or the zeros, negative 2 and positive 4. Our fourth step is to determine the equation of axis of symmetry. To determine the equation of axis of symmetry, it's very simple. You add the zeros and divide it by 2. Let me erase this in order to create space where we have to graph the relation or finish up the rest of the steps. To find the equation of axis of symmetry, or the x-coordinates of the vertex, we add the zeros and divide it by 2. So these are our zeros right here. Negative 2 plus 4. And then we divide it by 2. So this would be 2 over 2, which equal to 1. So the x-coordinates of the vertex is positive 1. How do we determine your optimum value? Your max or min value? In this case, it's maximum because opening downward. If it were to open up, then it would be minimum. But in this case, it's maximum. How do we determine our max value? By taking the value of axis of symmetry, substitute it back in origin equation for x to find the y-coordinates of the vertex. So let's do that. I'll erase this. So to find the y-coordinates of the vertex, we substitute an original equation for x, the value of axis of symmetry. So you have 1 plus 2, and you have 1 minus 4. So here to evaluate, finish the brackets first. 1 minus 4 is negative 3, and multiply them all out. So it would be negative 2 times 3 is negative 6. Negative 6 times negative 3 is positive 18. So the y-coordinates of the vertex, or your max value, is 18. Now we're ready to graph using all these information. So let me draw the xy plane. And like I said, you can use graph paper to draw it very accurately. And also you can find more information, more points on this relation, on this equation, by using a table value. Let x be anything, substitute and solve for y. You can find more points to draw it more accurately if you wish. But this is also good enough in order to graph the quadratic relation. So the y-intercept is positive 16. I'm just going to estimate. I'm going to say, assume this is positive 16 right there. And the x-intercepts are negative 2 and positive 4. Goes right on the x-axis. And the vertex is 1 and 18. 1 and 18 somewhere right there. And then we connect the points to show our U shape. Something like that. And that's the 1 and 18 as the turning point right there. So I'm sure you can do a lot better graph than myself here, but as long as the point is to understand how to graph this relation in factored form or any other relation. In the next video, I'll be explaining how to graph a quadratic relation from vertex form using the 5 steps. So I'm hoping that this was very productive and useful for yourself. Please don't forget to practice this question, particularly this example, a few times, and then you can apply it to your homework questions. Please don't forget to subscribe, and also if you have any question, leave in the comment box. And until next time, take care and good luck.